All right, everyone. Welcome back to another Python video. We're going to be looking and tackling two problems at once, the factor list and prime checker. The reason is because we're going to be using this function that we created to determine or create a list of factors of a number. We're going to use that in our isPrime function to check if a number is prime. So we're going to look at some function within a function happening and whatnot. Okay, so this is our testing area right here. We're going to be checking and looking at the list of factors for 13 and 36, and we're going to check if 13 and 36 are prime numbers when we test out this code. I wrote a keyword pass here just to say that right now it's not doing anything, and just really it's just an empty placeholder for our empty is underscore prime function. All right, but our factors, I set it up like so. We're going to create a list of factors of a number. We're going to assume that it is an integer greater than 0 for our argument, and we're going to return a list of arguments factors. Okay, just to starting off, we have an empty list. Our job is going to be growing that and then returning that list. Okay, so let's go. It's a numeric problem, so I'm going to use a for loop here. I'm going to say for dividers. And it's going to be coming from this set of range where we're going to start from num and we're going to include that num. So we're going to go num plus 1. So we're going to look at all the numbers from 1 to num plus 1. And then if this condition is true, as in if we take that given num, do a divider set to 0, we can say result, append, add that value to our divider because we have found the factor. And after that for loop is done, we should be able to find and output some nice list of factors. Okay. Now, one thing I do want to know is that when you have a function here and a function here, these are unrelated functions. Right now, this function doesn't depend on this, nor is this argument variable that we created for this function does not relate to these values at all. Okay. When you have an argument here, you are creating a local variable that is existing in the scope and allows us to pass on values like 13, 36, custom values that we can use as arguments so that we don't know what to call this. Therefore, we set up our arguments that way so that we can represent the arguments and the values that we are given in a scenario like this. And we get to use it in this scope. And as soon as you exit this code block, right, you can use that label again at a different function or a different state as long as it doesn't affect this function. And that is one key thing. You don't want any outer things affecting a function. You want your function to just be finishing its values and its calculation within its local scope. All right, so we have that set. We can now run our code. These two lines are not going to do anything. It's probably just going to output none. So here we can test our factors of 13 and 36. So let's run our code. All right, so factors of 13, we get 1 and 13, and 36 is 1, 2, 3, 4, 6, 9, 12, 18, and 36, like so. Therefore, all right, we are doing pretty well. We have created a function that is able to generate a list of all the integer factors that our given numbers would have, okay? So let's use that, okay? If we look at this, we have a really nice definition of a prime, as a prime should only have 2 values inside its factors list. So we're going to say, well, we can simply just return taking this number that's been given as an argument for is prime function, and we're going to use our factors function. We're going to say we're going to get the factors, and we're going to actually run that with this given argument called num. Okay, don't confuse it with this num right here. This value only exists with these this argument representing this argument or this argument. Okay, but now we're passing it on to a factors function that we just coded, and then we're going to run the length function on it. This will calculate, well, how many items do I have inside my list, right? This will be 2, and this will be 1, 2, 3, 4, 5, 6, 7, 8, 9 functions for 36. So if we say that, well, if that's equivalent to 2, then I should have a proper prime. So let's see how this one goes. We'll be able to say that, well, 13 is prime, so output is true, and for 36, it is false. So we get it is a composite number. Okay, so this is a nice little way to write a very simplistic function that you want something to do. This could be more readable as you write more complex code that utilizes an isPrime based function. Right, and here you're just really utilizing some of the functions that you might have wrote prior inside your other functions to make clean code and have your you don't have to rewrite this inside here and making a variation of this. Rather, you're taking advantage of this function that you created and just doing a simple comparison to actually and create another function that has another functionality. So that's a nice little easy thing that you can do. All right. Anyways, thank you for watching and stay classy.